resistors. So today's topic is we are going to study about combination of resistors. So we can say there are two combinations under which the resistors can be connected. One of the combination we are calling it out as series combination, where the resistors are connected in series, and another one we are taking it out as parallel combination. So parallel combination means the resistors are connected in parallel. See, if you are taking the resistors in series, first of all, let us consider the series combination. So in order to study about the effective resistance in series combination, let us consider three resistors. Okay, you consider three resistors. Let the three resistors be, let them be. I am taking the resistors as R1, R2 and R3 respectively. So how I can draw the diagram then? If you are taking the first resistor is represented like this. Let us take this as R1. Then let us consider this as R2. And take the third resistor as what? The third resistor as R3. When you are joining all the three resistors in series means the end of one resistor connected with the beginning of the other resistor. Like this it is going on. If so, then we are calling this combination a series combination. Let us take like this. The series combination of the resistors are connected to what? Are connected to a potential difference of V volt. See, in this combination, the charges cannot accumulate anywhere. There will be a continuous flow of charges. The charges cannot accumulate at one particular point. So the current that is passing through these electrical circuits or through the series combination of the resistors is a constant. But the potential difference across R1 varies as V1, potential difference across R2 as V2, potential difference across R3 as V3. See, when you are combining these three, the effective resistor can be written like this. All the three resistors can be represented or replaced by a single resistor Rs, which is connected to the battery. What we are in need of? We are in need of what is the value of Rs. So, how to get the value of Rs? Now, we have to say like this, since the charges cannot accumulate anywhere in the circuit, since the charges cannot accumulate anywhere in the circuit, anywhere in the circuit, the current flowing through the circuit is constant. So we can say the current I through the circuit, current I through the resistors, current I through the resistors is same or constant. But the voltage or potential difference across the resistors, potential difference across the resistors differ. So what are the potential difference across each and every resistor? Let us take like this. Let V1, V2 and V3 be the potential difference across what? Potential difference across the resistors. Okay, across the resistors R1, R2 and R3 respectively. Okay, then how? See, you are having V1, V2, V3 across what? Across R1, R2, R3. From where this V1, V2, V3 are coming means from the total potential V. So I can write, therefore, the total potential V is equal to sum of the three potentials V1 plus V2 plus V3. Let us take this as equation number 1. Now, according to Ohm's law, We know that according to Ohm's law, what we have studied according to Ohm's law, we can say that V is equal to I into R. Since V is equal to I into R, I can take like this. V1 is equal to, the current I is constant, but the resistance is different. So V1 is equal to I into R1. Similarly, what is the value of V2 and what is the value of V3? V2 is I into R2 and V3 is I into R3. Take all these values and substitute in equation 1. So substituting the values in 1, what you can able to get, V equal to, instead of V1, I am considering it as I into R1 plus I into R2 plus I into R3. How I can replace this or simplify this? Taking I as a common, I can write R1 plus R2 plus R3. What is V? But we can say V is the total potential. Total potential is total current I multiplied with the total resistance. The total resistance is replaced with the RS, the series combination. So taking this and substituting it here, I can write I into RS is equal to, on the right hand side, I will be getting I into R1 plus R2 plus R3. So this I and this I will get cancelled. So RS will be then equal to R1 plus R2 plus R3. So when the capacitors are connected in series, the effective capacitance RS is equal to sum of the individual resistances, not the capacitances, resistances. When the resistors are connected in series, then the effective resistance in series combination is equal to the sum of individual resistances. So how I can define? So I can define like this. When resistors are connected in series, when the resistors are connected in series, then the effective resistance, in the combination is equal to, effective resistance in the combination is equal to the sum of the individual resistances. Sum of the individual resistances. That is what we are taking or considering it as the combination. Okay, what is the note that we can write here? We can consider a note. What is the note here? The value of effective capacitance RS is always greater than R1 or R2 or R3. So how we can say this? The effective value in series combination is always greater than that of the greatest resistance in the combination. Am I correct? See, RS will be always greater than, RS will be always greater than the highest resistance in the combination. The highest resistance in the combination may be asked in one word question. So note it out. Take it as a note. Study about the next combination. The next combination is we are going to consider about the resistors in parallel. So let us consider three resistors which are connected in parallel. So let us take like this. Say we are having one of the resistance represented as R1, the second resistance which I am representing it as R2, and the third resistance we are calling it out as R3. So we can consider like this: R1, R2, and R3, three resistors which are connected in parallel to what? Which are connected in parallel to a potential V. As you know, when the resistors are connected in parallel, the potential difference across R1, potential difference across R2, potential difference across R3 are taken to be same, taken to be constant. But current that is flowing through the resistance differs because the value of resistances are differing. Let I1 be the current passing through the first resistor, I2 be the current passing through the second resistor, and I3 be the current that is passing through the third resistor. What is the effective capacity? What is the effective resistance of this combination? So the effective resistance of the combination is represented as Rp. So I am replacing R1, R2, and R3 with Rp connected across the potential P. So for this, we have to write a small description. So let us take like this. Let R1, R2, and R3 be three resistors connected in parallel. Three resistors connected in parallel across a potential of another potential difference of V volts. Here, the potential difference across the resistors is same. Potential difference across the resistors is same or constant. But the current flowing through them differs. But the current flowing through the resistors, that is through them, differs. Why differs? Because of different value of resistances. Because of different resistances. Okay. So let us take like this. Let I1, I2, and I3 be the currents passing through R1, R2, and R3 respectively. Okay. Now, what is the total current then? So I can write, therefore, the total current passing through the combination I is equal to total current is sum of the three currents, I1 plus I2 plus I3. According to Ohm's law, what we have studied, according to Ohm's law, I can state I is equal to V divided by R. Since we have studied like this, V is equal to I into R. So therefore, what is the value of I1? What is the value of I2? And what is the value of I3? I1 can be written as V by R1. V is a constant. I2 can be written as V by R2. I3 can be written as V divided by R3. And we can state the total current IS. If you are considering here, the total current passing through is I. If the total current is I means the total potential divided by total resistances. All the resistances are in parallel. So the total resistance, I am writing it as Rp. Now, you take all these quantities and substituting in equation 1. Take this as 1. So I am writing like this, substituting the values in 1. Substituting in equation 1. What you can get on the left hand side, instead of I can write V divided by Rp is equal to, on the right hand side for I1, I have to write V divided by R1 plus V divided by R2, and for I3, V divided by R3. Produce and or make a simplification. V divided by Rp equal to, take V as a common factor. We can write 1 by R1 plus 1 by R2 plus 1 divided by R3. So here one V get cancelled. So I can write 1 divided by Rp equal to 1 by R1 plus 1 by R2 plus 1 by R3. So how you can define the resistors in parallel? When the resistors are connected in parallel, the effective resistance in parallel combination has to be calculated as inverse. So the inverse of or reciprocal of the effective capacitance in parallel combination is equal to the sum of the reciprocal of individual capacitances. So how I can define? When the resistors are connected in parallel, when the resistors are connected in parallel, the inverse of the inverse of uh, effective resistance, the inverse of effective resistance is equal to the sum of the inverse of the sum of the inverse of individual capacitance, the sum of the inverse of individual capacitances, not capacitances, resistances, sorry. So individual resistances. Hope you should have understood. Here also I can write a note. What note I can write? The value of the effective capacitance or P will be always less than the least value of, it will be always less than the least value of the resistance in the combination. Resistance in the combination. The value of effective resistance in parallel combination is always less than that of the least resistance in the combination. This is called to be the effective resistance in parallel combination. Hope you should have understood. See, the circuit diagram given is you are having two resistors connected as shown. They are connected to a potential. The potential difference that was being available is given as 24 volt. There are two resistances. One of the resistance is given as 4 ohm and another resistance is given as 6 ohm. So from diagram, we can say that the two resistors are in series combination. Okay. What is asked? What is the effective resistance in the combination? RS is asked. Then R1 is given as 4 ohm. Then R2 given as 6 ohm. Let us consider. Then let us take this as R1 and this is R2 and this is the potential V. The potential V is equal to 24 volts. Apart from effective combination, they have also asked what is the potential difference across R1, because in series combination, current is constant and the potential difference varies. So let the current passing through the circuit, let us consider it as I. Potential difference across R1 as V1 and potential difference across potential difference across R2 as V2. So we have to calculate what is the value of RS, what is the value of V1 and what is the value of V2. First of all, you calculate the effective resistance in the series combination. As we know, RS is equal to, when they are connected in series, RS is equal to R1 plus R2, the sum of the individual capacitances. So the effective capacitance RS is equal to 4 plus 6 and the value of RS is considered to be 10 ohm. Okay. In order to calculate the potential across R1 and R2, I have to calculate the value of I. So according to Ohm's law, we know that V is equal to I into R. Therefore, the current I passing through the circuit is I is equal to V by R. So what is the value of V? V is 24 volt. R is 10 ohm. So the current available is 2.4 ampere. Then they have asked you to calculate potential across R1 and potential across R2. Potential or voltage. So voltage across R1, let us consider it as V1, which is nothing but general formula I into R. Since it is across R1, I am putting it as I into R1. I is 2.4. Multiplied it with R1. R1 is 4. So on multiplying, I can able to get 9.6 volt as the potential difference across R1. Similarly, potential difference or voltage across R2. Let us take it as V2, which is I into R2. What is I? It is 2.4. What is R2? It is 6 ohm. On multiplying 24 to 12 plus 2, 14. So 14.4 volt is taken to be the potential difference or the voltage across what? Across the resistances R1 and R2 respectively. Hope you should have understood this circuit first of all. So you are having two resistors connected in parallel, one below the other. And these two resistances are connected to a voltage or a potential difference. The potential difference V is equal to 24 volt. Let us take one of the resistances R1 given as 4 ohm and another resistance is R2 taken as 6 ohm. So you are asked to calculate what is the effective resistance in parallel combination. So in parallel combination, potential is same. So after that, what are the things they have asked? What is the current passing through each and every resistor? So I1 and I2 be the current passing through R1 and R2 means you are asked to calculate what is I1, what is I2, and what is the total current that is passing through it. Okay, first of all, let us consider the effective combination. The combination is taken to be what? The combination is taken to be parallel combination. So as you know, in parallel combination, the effective resistance is 1 by Rp equal to 1 by R1 plus 1 divided by R2. So I can write 1 divided by Rp equal to 1 divided by, instead of R1, we are getting 1 by 4, plus instead of R2, we are getting it as 1 by 6. So take an LCM, you can write 24. So 4 in the 6 in your 4, you will be able to get 10 divided by 24. It is considered to be 1 divided by Rp. So what is the value of Rp then? Rp is the reciprocal 24 divided by 10. If so, I can get the answer as 2.4 ohm as the answer. So effective resistance Rp is equal to 2.4 ohm. Then what is the current that is passing through each and every resistor? So let us let I1 and I2 be the current passing through R1 and R2 respectively. R1 and R2 respectively. Okay. So according to Ohm's law, we know that I is equal to V divided by R. If it is I have to put it out as IP. If it is I1, I have to consider it as V by R1. If it is I2, I have to consider it as V divided by R2. So first of all, if I am calculating I, total potential is 24. What is Rp? Rp is 2.4. So the total current passing through is 10 amperes. Isn't it? Similarly, if I am calculating I1, total potential is 24, but R1 is considered to be 4. So I1 is equal to 6 ampere. Similarly, what is I2? 24 divided by 6. So I2 is equal to 4 amperes. See, we can prove like this also. I is equal to I1 plus I2. I1 is 6, I2 is 4. Again, you can able to get I. 10 amperes. So we have calculated the effective resistance Rp, the total current I, current through the resistance R1 and current through the resistance R2. So let us take like this. Let R1 and R2 be the two resistances. Let R1 and R2 be the two resistances. When they are connected in series. So the series combination RS is given as 15 ohm. When they are connected in parallel, the combination value is given as 56 divided by 15 ohm. What is the value of R1 and what is the value of R2? This was the question asked. So how to proceed? First of all, let us consider the series combination. See, when R1 and R2 are in series, when R1 and R2 are in series, then I can write like this: RS is equal to R1 plus R2. So on simplifying, I can write like this: R1 plus R2 equal to, instead of RS, I can put it as 15. Take this as equation number 1. Similarly, when connected in parallel, when R1 and R2 are in parallel, what will happen? If they are connected in parallel, then I can write 1 by Rp equal to 1 divided by R1 plus 1 divided by R2. See, I am simplifying this. 1 divided by Rp equal to, I am taking LCM. So on taking LCM, denominator, you will be getting R1, R2. In numerator, you will be getting R2 plus R1 or R1 plus R2. So from this, I am writing Rp, resistance in parallel. Taking reciprocal, I will be able to get it out as R1, R2 divided by R1 plus R2. Am I correct? If so, you substitute. What is the value of Rp? Rp is, so substituting in this equation, we get Rp. Instead of Rp, I can write 56 divided by 15 equal to R1, R2, I don't know. So I am writing R1 into R2 by R1 plus R2. What is R1 plus R2? You see, R1 plus R2 from equation 1, it is 15. So in the 15 and this 15 will get cancelled. So what I can able to get? Therefore, R1 into R2 will be then equal to, I will be able to get it out as 56. Take it as equation number 2. See, from this equation number 2, I am writing like this. From equation 2, you calculate either the value of R1 or R2. Say I am calculating R2. R2 in terms of R1. So R2 will be then equal to 56 divided by R1. Take this as equation number 3. Am I correct? Now, you take this equation 3 and substitute in equation 1. Substituting equation 3 in equation 1. Come on, substitute. Instead of R1, R1 as it is. Plus, instead of R2, we can write 56 divided by R1, which is equal to 15. Now, you multiply this equation with R1 so that you can able to get a second order quadratic equation. Multiply the above equation with R1. What you will able to get? When you are multiplying the first term with R1, you will be getting R1 square. Plus, when the second term is multiplied with R1, R1 will get cancelled. So you will be able to get 56. Is equal to, by multiplying with R1, we can get 15 R1. Rearrange this. On rearranging, we can get R1 square minus 15R plus 56 is equal to 0. You take the root for this. This is in second order quadratic equation. Root எடுக்க தெரியும்ல? How? By taking the T form. So you are getting 56 here plus 56. We have to get minus 15. So I am writing minus 8 and minus 7. So my 8 into 7, 56. Minus 8 minus 7 is plus 56. When I am adding, I can able to get minus 15. So I can write the roots as r minus 8 and r minus 7, which is equal to 0. So I will be able to get it out as, that is r1 minus 8, r1 minus 7. So I will be getting r1 is equal to 8 ohm, or r1 may be equal to 7 ohm. You are having two options. R1 may be equal to 8 ohm, or R1 may be equal to 7 ohm. So using this, I have to calculate R2, because R1 plus R2 is equal to RS. From equation 1, substituting in equation 1, we can calculate the other value. So case 1, I am taking it like this. Case 1, if R1 is equal to 8 ohm, then what is the value of R2? R2 equal to 15 minus 7, which is equal to 8 ohm. Or if R1 is equal to, I can take it out as case 2. If R1 is equal to 7 ohm, then R2 will be then equal to 15 minus, see, the first one is wrong, isn't it? If R1 is equal to 8 ohm, then I have to write 15 minus 8, that is 7 ohm. Then in case 2, if R1 is equal to 7 ohm, then R2 equal to 15 minus 7, I will be getting it as 8 ohm, isn't it? If you can take like this, if R1 is equal to 8 ohm, then R2 is equal to 7 ohm. If R1 is equal to 7 ohm, then R2 will be then equal to 8 ohm. So what are the two resistances? So I can write the answer like this. The two resistances are, the two resistances are 7 ohm and 8 ohm respectively. That we are calling it out as the problem number 2.10.